please feel free to subscribe to this sideshow.
Right, I'm now going to ask you to solve a little problem from the playlist that I've put on Facebook, and that is to sum this particular series to n terms. I gave you a little bit of a hint, I think, but nobody seems to have come up with the answer, which has left me quite heartbroken. Okay, so very, very heartbroken. So I'll now show you that it's not all that difficult. Now, when you first see that, you'll probably start fishing around to looking for patterns to see if you can make the work easier. You will find some patterns, but they will become so convoluted that you'll just rip up your paper and start again. So let me show you the way I do it. So I'm going to write down, instead of the series we've got, the corresponding series, but with nines. 99 plus 999 plus, and so on to n terms. Now this is where the magic is going to come in. What I'm going to do is add on ones underneath here. And then add those up. And what we'll get is 10 plus 100 plus 1000 plus 10,000 and so on, n terms. Well, even those of you who've probably slept through your mathematics lectures will recognize that as a geometric progression with the first term 10 and the common ratio also 10. And the sum to n terms of that will be 10 bracket 10 to the power of n minus 1 divided by 10 minus 1. And the bottom, of course, will just be 9. Now then, that is this particular series here. The one above it, the one with all the 9s, will be n less because we added on 1 n times. So that will be n. And so simplifying that, what do we get? We get 10 to the power n plus 1 minus 10, and the bottom will be just 9. And if I include this particular n as part of that fraction, it becomes 9n. And that, my friends, is it. Right, now that is the sum of the series with all the 9s in it. The one with all the 1s in it will obviously be 1/9 of that. So our final answer will be, in a different colour, 10 to the n plus 1 minus 10 minus 9n, and the entire thing divided by 81. And that is the answer to the top. See how easy it is? Finished. All right, I've just proved that 1 plus 1, 1 plus 111 plus 1, 1, 1, 1, etc. to n terms is given by this little formula here. So that suggests that the top of that is a number which is always, as long as n is a positive integer, divisible by 81. Well, of course we can know that because this is equal to a whole number here. But if on an examination paper you were given just that top expression and asked to prove that that was divisible by 81, what do we do? So let fn, function of n, equal what I've written down there, 10 n plus 1 minus 10 minus 9 times n. And then if we replace n by n plus 1, what do we get? F of n plus 1 will equal 10 n plus 1 plus 1, which is 10 n plus 2, minus 10 minus 9 times n will become minus 9 times n plus 1. So that will be 9n minus 9. All right? Which, if you wanted to simplify it, is 10 over n plus 2 plus 9n minus 19. All right? Okay. Now then, let us multiply this expression here by 10. So we get 10 times f of n will equal 10 to the power n plus 2 minus 10, or minus 100, sorry, we're multiplying by 10, minus 90n. And take the difference between the two expressions in green letters. So what we'll have is f times, or 10 times fn minus f of n plus 1. What will that give us? Well, the terms 10 to the n plus 2 will disappear, and what will we get left? So we got minus 100. I think I should do this the other way around, but it doesn't really matter. F n plus 1 minus 10 times fn. What will that give us? They say the 10 to the power n plus 2 will disappear. Minus 10 minus minus 100 is, sorry, we're back over here to this expression here. That will be 9n minus 90n will be 81n, and minus 19 minus minus 100 will be plus 81, which you can see is divisible by 81, very obviously. So if f of n is a multiple of 81, then so must fn plus 1 be. Can't be otherwise. Repeat that. If f of n is a multiple of 81, then so must fn plus 1 be. Okay, but f of 1, what does f of 1 equal? Let's go back to there. F of 1 will be 10 squared minus 10 minus 9, which is 100 minus 19, which is 81. So f of 1 is obviously a multiple of 81. But what we've seen here, that means f of 2 must be, and so therefore f of 2 is a multiple of 81. And again, repeating what we've just done. So f of 3 will be a multiple of 81, and so on to the last syllable of recorded time. So it's true for all integers n. That last bit just gives you a glimpse of the induction method. Yep, this should have written as multiple of 81. Okay, thank you.
Please feel free to subscribe to this sideshow